In this video, I will attempt to explain dynamic equilibrium. Let's begin by looking at the meaning of dynamic and equilibrium. Dynamic is an adjective used to describe a force or power related to motion. Think about a pendulum that's set. Equilibrium exists when a reaction and reverse reaction proceed at equal rates. Picture two people balancing on a seesaw. Here is another way to think about dynamic equilibrium. Imagine that you are on an escalator and you are walking up at the same rate that the escalator is going down. You ultimately are trying to stay at a fixed point. The conditions are the same for systems of dynamic equilibrium. They are always changing in terms of mass and energy. They maintain a single appearance or identity, and the systems of dynamic equilibrium are closed. The video segment that follows has a great illustration of the features of a closed system in dynamic equilibrium. It is presented by the University of Surrey in the UK.
If the wet towel is left in a closed sports bag, it does not dry. High-energy water molecules evaporate and remain as vapor trapped in the atmosphere around the towel. At the same time, low-energy vapor molecules condense on the surface of the towel to a liquid. The rate of evaporation exceeds the rate of condensation until the vapor becomes saturated. At this point, a balance is reached where the rate of evaporation equals the rate of condensation. A state of dynamic equilibrium is reached, represented by a double-headed arrow. Dynamic equilibrium only occurs in closed systems.
A textbook model of dynamic equilibrium looks like this. The reaction pictured is in dynamic equilibrium because products are being converted to reactants and reactants are being converted to products. The model is inaccurate because it shows that the number of reactants and products is the same. It is easy to have this misconception because of the use of the word balanced when discussing equilibrium. However, the number of molecules pictured are limited and does not accurately show movement and change. Remember, the system is always changing. Sometimes there may be more molecules of A, and other times there may be more molecules of B. This concludes my presentation of dynamic equilibrium. I hope the illustrations and examples provide a black and white explanation of a system and a state of dynamic equilibrium.